Hello, I'm Kelly Virgilio from Luna Labs at Luna Innovations. We are developing a wearable posture support system to reduce fatigue and pain associated with long-duration flights. This technology has been specifically designed for military aviators, and if you have a need to reduce pain and fatigue to improve situational awareness, flight crew readiness, and performance, we would love to talk to you about our technology. Luna was founded in 1990 and is headquartered in Roanoke, Virginia. Since our founding, we've grown to approximately 400 employees. Luna has developed SBIR-funded technologies that are currently being used in multiple infrastructure and aerospace products, including a corrosion monitoring and sensing product that's now being used in the Orion spacecraft crew module and in the CH-53K helicopter. Luna is split into two major divisions. The Lightwave division primarily works in the development of fiber optic sensing methods and equipment. Luna Labs, where this project is based, is the applied research arm. Luna Labs has over 70 engineers, of whom about half hold advanced degrees. We're focused in three primary subgroups, including material science, embedded electronic systems, and biotechnology. In the biotech space, which includes our human interfacing and performance technologies, we've recently completed 2 SBIR programs that transitioned to commercial sales prior to the end of the Phase 2, demonstrating our commitment to commercializing our technologies. This unique arrangement of Luna Labs, with our 3 divisions working together, allows us to tackle and provide robust solutions to a massive range of engineering challenges. The goal of this project is to develop a wearable posture support system to mitigate fatigue and pain in rotary flight crew. To ensure mission success, flight crew must maintain peak performance for extended periods of time. During this time, they must wear heavy vests, helmets, and additional helmet-mounted masks, and often sit in uncomfortable and suboptimal positions. This can lead to both acute and chronic pain, a significant distraction that may reduce their ability to focus on the current mission. So by addressing this pain and fatigue, aircrew can maintain their focus and awareness, ultimately improving performance. And in the long term, this can reduce the prevalence of chronic pain and injuries, leading to an overall increase in aircrew readiness and potentially even crew retention. Our initial transition targets within the Navy are PMA 202 aircrew systems. We believe this office stands to benefit the most from immediate application of this technology, and our support system was designed to be a rapidly implementable solution to a long-standing challenge. So what makes this different from other wearable posture support systems? Luna's system is specifically designed for rotary aircrew. We understand that aircrew already wear a significant amount of gear. So we designed the system to be low profile so that it can be worn above the flight suit but under the vest with minimal added weight and bulk. To ensure that it is comfortable and supportive for the entire flight, the system can be easily adjusted through dials that are easy to access with full flight gear. This aircraft-independent solution is easily adaptable and requires no airframe changes for more rapid implementation. This rapid implementation is critical because musculoskeletal pain has continued to be identified as an issue of significant importance to the fleet. As the Navy continues to develop innovative technologies to optimize flight crew protection and performance, the additional loads placed on aviators for increasingly long mission durations can lead to muscle fatigue and injury, particularly in the lower back. Chronic injuries and pain not only affect current flight performance, but can have significant long-term costs through lost workdays, reduced readiness, increased medical costs, and even reduced pilot retention. Beyond the Navy and even beyond the DoD, there are significant opportunities to extend this technology to additional markets, such as commercial pilots and long-haul truckers. To address this significant need, our device counteracts loading from body-worn masses through a back tension element that has been optimized to offload the added weight from the vest and head-mounted masses. This optimization is critical because a system that applies too much force down the back would actually increase loading on the spine and make the issues even worse. We worked with the world's largest university-based injury biomechanics lab to perfect this loading. The device also includes inflatable and adjustable lumbar support to stabilize the core. This will help maintain proper posture and reduce pain and fatigue from the vibrational loading. As you can see on this image, the dials are easily accessible under the flight vest, allowing for complete adjustability in flight and ensuring aviator comfort. The device is low cost, low profile, and low weight, and allows for complete mobility to ensure unhindered egress from the aircraft. Critically, in a comparison to costly and time-intensive changes to the airframe, this solution can be rapidly implemented without extensive delays. Since this is a rapidly implementable solution, we have already produced multiple generations of prototypes and are currently working with our military soft goods manufacturing partner to produce devices across multiple sizes. We have used computational modeling at our partner Injury Biomechanics Lab to demonstrate a reduction in loading and are currently preparing to complete human study evaluations to quantify the reduction in muscle and vibrational loading with our device. To prepare for the human study, we will produce 100 units with our manufacturing partner in preparation for complete qualification testing. If you're not already convinced that our solution will provide you with significant benefits and improvements, let me lay out a few more scenarios for you. For mission readiness and protection, Aircrew gear can include front-heavy vests, helmets, and night vision goggles. In the best conditions, if these loads were unmitigated, they would lead to muscle fatigue. But in the flight environment, aircrew are also subjected to significant vibrational loads. Pilots sit in a helo-hunch posture, while flight crews are often in compromising positions for in-flight operations. These suboptimal postures mean muscles are being used incorrectly to maintain positions, and the added loads and vibrations increase muscle loading beyond what can be comfortably and reasonably maintained for the extended flight durations. Together, this creates an environment of chronic fatigue and injury through continuous improper use of muscles in the core, back, hips, and beyond. We have stressed that this can affect flight operations, but chronic pain is also a significant quality of life issue that can affect aviators or individuals in similarly demanding careers for the rest of their lives. Our solution first counteracts the loads from the added weight and then stabilizes the core so that flight crew can maintain proper posture at a reduced energy cost, meaning your muscles are functioning as they're meant to, and they don't have to work so hard to maintain a position. Over time, this should significantly reduce fatigue and injury. Clearly, reducing pain and fatigue during flights will allow aircrew to focus on their mission rather than their pain, increasing performance and lethality. We have over a decade of experience in developing human interfacing solutions for optimizing warfighter performance, and we are confident that we can deliver a solution with significant advantages to our customers at a low cost and on a rapid schedule. During our design stage, we used advanced modeling and worked with world leaders in injury biomechanics. Now, we are moving towards relevant environmental testing that includes a human study with a flight simulator and imposed vibrational loads. We will assess how our solution reduces both loading on the air crewmen and pain. Of course, quantifying the effect of our system is critical, but it's equally important to see what current Navy pilots think of this design. Throughout this development, Luna has been in contact with numerous former and current pilots and is in the process of sending prototypes to our program monitors and NAVAIR. As soon as we receive final feedback from the human studies and pilots, we will be ready for low-rate production because we're already working with our manufacturing partner. To complete transition of this technology, we are looking for a partner for initial deployment of our wearable to verify the performance gains during and post-flight. Beyond just the DoD, there's a wide range of customers who are interested in a wearable posture support device to reduce pain and fatigue. Musculoskeletal pain is a leading healthcare cost in the United States, with annual costs totaling over $100 billion. We think our low-cost, easy-to-implement, scalable, and adaptable solution can provide needed relief to a large segment of that market, including both military and non-military customers. We are producing a detailed market report to help us identify these customers and aid in outreach and scale-up for transition. Luna performs these type of assessments on products that are being positioned for military and commercial transition to help ensure a successful device partnership and transition process. This slide shows a rough workflow for how we envision a transition process may go with a Navy partner. We're in the blue section right now. We are working to build relationships with you, a potential transition partner, while we are advancing our technology and validating it with human studies. We will then need guidance from our partners to help identify things like pre-deployment testing requirements and identify a fleet for relevant testing. After this testing is complete, we can begin expansion into full-scale manufacturing. By partnering earlier with us, there are massive benefits. Most importantly, in an environment where we are constantly aiming to optimize warfighter performance and lethality with often costly and time-intensive solutions, you can be first in the door to test a low-cost, low-risk solution to reduce fatigue and injury and increase aircrew awareness, readiness, and performance. So if you have a need to optimize aircrew performance, please come talk to us. We would love to hear about your specific needs and challenges in this space. If the problem is similar, but you have unique challenges or obstacles, we'd love to see how we can adapt our current technology to improve your performance. Just navigate over to the virtual booth tab on the conference webpage and search for Luna Innovations. We have several folks available to talk, and we would love to connect with you. Our contact information is shown at the bottom of this slide. I want to thank you for your attention.